This is section 10.1 part A, the sampling distribution of a difference between two proportions. Suppose we want to compare the proportions of individuals with certain characteristic in population 1 and population 2. Let's call these parameters of interest P1 and P2. The ideal strategy is to take a separate random sample from each population and to compare the sample proportions P hat 1 and P hat 2 with that characteristic. What if we want to compare the effectiveness of treatment 1 and treatment 2 in a completely randomized experiment? This time, the parameters P1 and P2 that we want to compare are the true proportions of successful outcomes for each treatment. We use the proportions of successes in the two treatment groups P hat 1 and P hat 2 to make the comparison. Here is a table that summarizes these situations. So we have two different populations or treatments. We have population 1 or treatment 1, and we have population 2 or treatment 2. For each of these populations or treatments, there is a parameter of interest, P1 and P2. And for each population or treatment, there can also be a statistic taken because of the sample from that population, and we would have P hat 1 and P hat 2. And we're going to have sample sizes for each population or treatment, and that would be N sub 1 and N sub 2. Those sample sizes do not have to be the same size, so we do have to distinguish which one is which. We compare the populations or treatments by doing inference about the differences of P1 minus P2 between the parameters. The statistic that estimates this difference is the difference between the two sample proportions P hat 1 minus P hat 2. To use P hat 1 minus P hat 2 for inference, we must know its sampling distribution. So if we choose a simple random sample of size N sub 1 from population 1 that has a proportion of successes of P1 and is an independent simple random sample of size N2 from our population 2 with a proportion of successes of P2. So first we need to check the shape. When N1 times P1 and N1 times 1 minus P1 are at least 10, we know that it's approximately normal. Also, we can do the exact same thing for the second population, so N2 times P2 and N2 times 1 minus P2, again, is at least 10. We know that it's going to be approximately normal. And so, because both of them are approximately normal, we can then say that the sampling distribution of P hat 1 minus P hat 2 will also be approximately normal. So basically for the shape, you're just going to check that the first population is approximately normal because the number of successes and number of failures are both at least 10. You will do the same thing for population or treatment 2. And as long as both of those populations or both treatments are approximately normal, then we can say the difference of those populations or treatments would also be normal. For the spread, the mean of the sampling distribution will just be P1 minus P2. For the center, that would be the mean. And for our spread, the standard deviation of the sampling distribution of P hat 1 minus P hat 2 is going to be given by the square root of P1 times 1 minus P1 all over N1 plus P2 times 1 minus P2 all over N2. As long as each sample is no more than 10% of its population. Finding probabilities with the sampling distribution. Suppose that there are two large high schools, each with more than 2,000 students in a certain town. At school 1, 70% of the students did their homework last night. Only 50% of the students at school 2 did their homework last night. The counselor at school 1 takes a simple random sample of 100 students and records the proportion P hat that did homework. School 2's counselor takes a simple random sample of size 200 students and records the proportion P hat 2 that did their homework. School 1's counselor and School 2's counselor meet to discuss the results of their homework survey. After the meeting, they both report to their principals that P hat 1 minus P hat 2 was 0.10. So for this problem, we need to describe the shape, center, and spread of the sampling distribution of p hat 1 minus p hat 2. So let's start with the shape. To determine the shape, we have to make sure that each distribution is normal before we put them together, before we find the difference. So for the first population, you're going to do n times p, make sure that number is at least 10 or greater. And then you're going to do n times 1 minus p and make sure that's at least 10 or greater. For n times p, we got 70 successes and 30 failures for population 1. Both of those are greater than 10, so we are good. For population 2, our number of successes is 100. Our number of failures is 100 as well. So in this case, there is at least 10, so that works. Since both populations are approximately normal, we can say the sampling distribution would also be approximately normal. Next, we need to find the center. To find the center, all you're going to do is take your P1 and subtract your P2. Our P1 in this case was 0.7. Our P2 is 0.5. So if we subtract those, we will get 0.2 as the mean or the center for the difference between the two populations. And then last, we need to find the spread or the standard deviation. To find our standard deviation, we're going to do the square root of the probability of success times the probability of failure over the sample size for population 1, plus the probability of success times the probability of failure over the sample size for population 2, and we're going to take the square root of that entire thing, and we're going to get a standard deviation of 0.058. Next, we need to find the probability of getting a difference in sample proportions of p hat 1 minus p hat 2 of 0.10 or less from the sampling survey, and we need to show our work. So in this case, we are going to find our z-score, and then we're going to find the area under the curve that falls to the left of that. So we know that p hat 1 minus p hat 2, that they told us was 0.10. We found in that previous example that our center, or our mean, was 0.2, and our standard deviation was 0.058. So to find the z-score, we're just going to do p hat minus p all over the standard deviation, or 0.10 minus 0.20 all over 0.058, which is going to give us a z-score of negative 1.72. Now, if we have the z-score of negative 1.72, to find the probability that it's this value of 0.10 or less, that's the area to the left. If you know your z-score and you go to your table A or your z-score table, it'll tell you the area to the left of this. And if we look that up, the probability that z is less than negative 1.72 is 0.0427. So the probability that P1 minus P2 is less than 0.10 is about 4%. Do the results in Part B give us reason to doubt the counselor's reported value? Explain. There's only about a 4% chance of getting a difference in the sample proportions as small or smaller than the value of 0.10 reported by the counselors. This data seems suspicious. So let's check our understanding. Your teacher brings 2 bags of colored goldfish crackers to class. She tells you that bag 1 has 25% red crackers and bag 2 has 35% red crackers. Each bag contains more than 500 crackers. Using a paper cup, your teacher takes a simple random sample of 50 crackers from bag 1 and a separate simple random sample of 40 crackers from bag 2. Let p hat 1 minus p hat 2 be the difference in the sample proportion of red crackers. What is the shape of the sampling distribution of p hat 1 minus p hat 2 and why? Remember to check the shape. You're going to make sure that each distribution is approximately normal, and if both of them are approximately normal, we can say that the difference would also be approximately normal. So you are going to check that the number of successes and the number of failures, or n times p and n times 1 minus p, for both groups would be at least 10. So for population 1, the number of successes is 12.5, the number of failures is 37.5. For group 2, the number of successes is 14, and the number of failures is 26. All of those values are at least 10, so the sampling distribution of p hat 1 minus p hat 2 would also be approximately normal. Find the mean and the standard deviation of the sampling distribution and show your work. Remember, to find the mean, all you're going to do is just subtract the means of your two proportions. So we're going to do P1 minus P2, or 0.25 minus 0.35, which will give us a mean or a center of negative 0.1. To find the standard deviation, you're just going to take the square root of the probability of success for group 1 times the probability of failure all over the sample size, plus for group 2, the probability of success times the probability of failure all over the sample size. And in this case, we're going to get a standard deviation of 0.0971. Find the probability that p hat 1 minus p hat 2 is less than or equal to negative 0.02 and show your work. When we have to find the probability, we are looking for the z-score. So remember, z-score in this case is going to equal p hat minus p all over the standard deviation, or our p hat in this case is negative 0.02 minus what it was for the hypothesis, which was negative 0, or the mean was negative 0.10, all over our standard deviation of 0.0971. And this is going to give us a z-score of 0.82. Now, since we're finding the area to the left of this, because we're finding the probability that it is less than or equal to this, we're going to look on our table A. We're going to find the z-value of 0.82, and it's going to have an area to the left of that of 0.7939. So there's about a 79% chance that we get a difference of negative 0.02 or less. Based on that answer, would you be surprised if the difference in the proportions of crackers in the two samples was 0.02, and explain? We would not be surprised because it's about a 79% chance of the samples would have a difference of 0.02 or less. So we would not be surprised with this answer.